When an organization attempts to overhaul its core operations, the documentation follows. Thousands of requirements, process maps, and architecture documents are stacked together in an effort to capture every detail. We use traditional tools to tie these elements together. Every business rule is mapped to a user story, and every user story is mapped to a capability. On paper, this creates a system that appears ready for development. But there is a gap between a system having a clear structure and its underlying logic actually aligning. Just because two requirements share a connection in a database doesn't mean they make sense when executed. You can link a formatted process map to a specific requirement and still end up with conflicting rules that only surface during the build. This illusion of structure explains why projects that look healthy on a tracking dashboard often fail the moment engineering attempts to turn those documents into a working system. There is a specific moment right before the handoff to delivery where teams often hesitate. They look at the thousands of interconnected items they're about to commit to code and realize the architecture is hiding layers of unresolved ambiguity. Traditional management tools offer little help here. They are designed to store objects and track their status, not to evaluate the logic encoded within the text itself. The common response is to produce more documentation. However, generating more data and more traceability links often just creates more noise, making it harder to see what is actually broken. To stop late-stage rework, we have to move past managing data objects. We have to start evaluating the quality of the thinking behind them. This is the role of ALManac. It is designed as an orientation system, separating the task of understanding the system from the task of simply storing its requirements. The process begins by connecting the disparate layers of the business context. It brings together epics, BPMN flows, data models, and user journeys into a single environment. ALManac doesn't just link these items, it analyzes the underlying intent and alignment across the model. This shifts the team's perspective. Instead of reviewing isolated documents, you are looking at a unified map where the system's logic is measurable. By exposing the internal logic of the model before delivery begins, ALManac identifies the specific technical gaps that typically hide behind a ready status in a standard database. This dashboard shows how that readiness is quantified. Rather than relying on guesswork, the system generates a coherence score based on quality dimensions like intent completeness and structural clarity. The engine identifies cognitive failures within the documentation. It detects when a requirement lacks clear intent, or when the phrasing is too ambiguous for an engineering team to implement. It also maps overlapping logic and broken traceability paths. This heat view highlights exactly where the system's structural integrity is weakest by flagging problematic nodes in red and yellow. These vulnerabilities, missing intents, duplicate logic, and deaded links, are the primary causes of architectural rework once the build starts. The errors that break delivery were already there. Traditional tools simply couldn't see them because they weren't designed to read meaning. In most large organizations, there is constant pressure to generate more documentation and more administrative reports. ALManac is built on the opposite principle. It does not add more processes or more data to the workload. It acts purely as a signal. It reveals what already doesn't make sense, so it can be corrected when the cost of change is at its lowest. Cognitive infrastructure like this changes the definition of success. It shifts the focus from the volume of data collected to the validated integrity of the model itself. There is a heavy industry focus on building faster, but speed is a liability if it forces you into rebuilding broken systems later. Meaningful acceleration only happens when the foundation is logically sound before the handoff occurs. The goal here isn't simply to accelerate the initial build, it's to ensure the resulting system has the structural integrity to actually hold.